All right, here's another example. So now again, we're looking at two population means, independent samples, but this time we don't know the standard deviation. So we have to use the t-distribution, t-test, t-statistics. So again, process is the same. State the hypotheses, figure out alpha, the test statistic, p-value, make a decision. So again, similar process. You have a test statistic, which is the difference between your point estimate and some value, which is typically the difference between the means of the two samples or population, which we assume, right, is going to be 0, divided by the standard deviation. Again, the only difference when you're using the t-distribution is you have to know the degrees of freedom, which is contingent upon the sample size. But in this case, when you're dealing with two populations and then you have two samples, sometimes your sample sizes aren't equal. So look at that formula. It's pretty intense for figuring out what the degrees of freedom are. So that's why, again, it's nice to have software to be able to do that for you. But again, similar concept that you need degrees of freedom to figure out which type of distribution from the family of t-distributions, of that family of distributions you need to use. So again, let's just jump right into an example. So we're looking at college cost. Let's see, the following random samples show the annual cost of attending a private or public college. Data are in the thousands of dollars. So again, we're comparing prices for colleges, whether they're private or public. So again, we have two populations that we're trying to compare. We could collect a sample, we find the differences between their means, and we use that point estimate, right, and we make statements about it to determine what's going on with the populations in terms of which one is maybe more expensive. So let's go to Excel. So here's the data. Here's the cost in thousands of dollars, remember, for someone going to a private school versus here's a bunch of observations of people and the cost that they spend at a public school. So again, we're going up to the top to data, over to the right under analysis, we're going to data analysis. And again, we have our different two populations options. So again, this is an independent, right? So we know we're not using paired, they're independent samples. So we are actually going to use the t-test, right? Because we don't know the standard deviation of the population. Then obviously you see you have two options. One assumes equal variances and the other assumes unequal variances. So basically this is just saying, hey, for the standard deviations of the variances of the population, are they equal or not? Well, sometimes you don't always know, right, what they are. So if you don't know, you can't assume that they're equal. So a more conservative test would be to assume that they're unequal. So especially if you don't know, go with a more conservative test that assumes unequal variances. So that's what we're going to select, the t-test for two samples assuming unequal variances. So select OK. And again, a box will come up where you have to enter information. So we have variable 1. So we have private, and then public is for 2, that range. Again, select labels because, as you can see, I included the labels private and public in there. Alpha, I think, is 0.05. The hypothesized mean difference is 0. And output, where do you want to put that? I'm going to put this down here for right now because I already have the output, as you can see. And just hit OK. And then, again, all the output that I just did is already up here. So again, you'll notice the means are calculated. You can find the difference, right? So the difference is just equal to private minus public, right? And so the difference is 20.2. But remember, this is in thousands of dollars. So if you want to know actually what the difference is, just take that value, 20.2, and multiply it by 1,000 because it's in thousands of dollars. And that will tell you that the mean difference between cost of private and public school on average is $20,200. That's a pretty big chunk of change, people. Okay, so we have the variances and the standard deviation. So this was calculated for us, right, because we don't know the standard deviation or the variance of the populations. So we have to estimate it from a sample. So this is a variance. So if you want to know what the standard deviation is, you just take the square root of the variance. So this is what our standard deviation is. It helps us, again, it's a little bit more intuitive to understand the standard deviation compared to the variance. So you can look at that, and basically this is, again, multiply that by 1,000. It will give you the standard deviation for each of these samples. So this one's about $7,000. This one's about, what, $4,500 for the standard deviation. So it gives you a little idea, an indication as to the spread of the data. So first thing you'll notice that $20,000 is a huge difference. And then the standard deviations aren't too big relative to this. So we might start thinking that, yeah, this is probably statistically significant. Remember, it's also contingent on sample size. We don't have a huge sample size, but this difference is pretty big. Observations, that's just our sample size. Degrees of freedom. Remember that long formula that I showed you? That was intense, right? Imagine doing that by hand. Ooh, big. So Excel's nice enough to do it for you. Then we have the t-stat, right? Remember, somewhere around 2, around that value says that usually if you have a value that's greater than that, it's statistically significant. So again, that's a great indication that this is probably significant. I don't think there was a hypothesis in terms of direction, so I think it was just looking at, is there a difference? So we want to go with the two-tailed test. So again, we can compare our critical value and our t statistic. This one is obviously much bigger than the critical value, right? It's beyond, right? Our t statistic is beyond, greater than this critical value, so we would reject the null, that there's no difference in the prices, the average price for private and public schools. And then we look at the p-value. So I want you to be careful with this because it looks like it's 1.05, which is, it seems huge, but remember to see that this has e to the negative 6. So basically what that means is move this decimal point 6 spots to the left. 1, 2, 3, 4, 5, 6. So it's like 0.000000105 or whatever. Count the zeros. There would be 5 zeros. So that's extremely small, right? You want me to write that out for you? 0.12345 for rounding. Right, that's what it basically looks like. So that's small. That's definitely less than 0.05. So we're definitely looking to reject the null. And so that's the conclusion that we come to. We would reject the null and say that, the average cost of public education is significantly less than that of the cost to attend a private school. So again, that's all that there is to it. But again, if you have questions, comments, or concerns, just let me know. Oh, one thing I did want to point out, I keep forgetting to tell you this in the videos. When you selected the labels, if you include them, see, it does come up here and say private and public and makes it easier. Otherwise, it's not going to do that. And so just labeling helps make things clear for presentation of your data.